Hello everyone. So today we're going to solve the back questions of the chapter 7, that is solutions. Okay, so let us start. Okay, so the first question is, what do you understand by ideal and non-ideal solutions? So we can say that an ideal solution, if all the components in that solution mix uniformly without any major changes. So there is no changing properties like their boiling point, their freezing point, nothing is changing here. And without any changes in the properties, if the components mix uniformly, then it is known as an ideal solution. And the forces between the molecules, that is, whatever the forces there between the molecules before and after mixing will be same, and there will not be any kind of heat absorbed or released when they mix, and it follows Raoult's law at all the concentrations. So this is what an ideal solution is. Basically, an ideal solution means we can say that if all the components in a solution mix uniformly without any changes in the property, and the force, if it remains same before and after mixing the molecules, then it is known as an ideal solution. Non-ideal solution means, so ideal solution follows Raoult's law. Non-ideal solution does not follow Raoult's law. And we can say that the forces between the molecules will change after mixing, which can either increase or decrease the total vapor pressure. So the forces between the molecules. So when we mix the molecules, there is change in the forces. Either the force can increase or decrease due to the vapor pressure. This is known as non-ideal solution. Okay. So that is all about ideal and non-ideal solutions. Next is define freezing point and boiling point. So freezing point means the temperature at which a liquid turn into a solid. That is known as freezing point. So there is a specific temperature at which a liquid will turn into a solid. So this temperature, liquid and solid will exist together in an equilibrium. That is freezing point. For example, water will freeze at 0 degrees Celsius under the normal condition. So what will be boiling point? The temperature at which the liquid will start forming bubbles and will change into vapor. That is known as boiling point. And this happens due to the vapor pressure of the liquid. That is, when the vapor pressure equal to the atmospheric pressure, it will start forming bubbles and will change into vapor. That is known as boiling point. For example, water will boil at 100 degrees Celsius. Now, next is derivation. So let's do that. Derive the relationship between that. Okay, so we need to derive this relationship. Delta T is equal to Kb into M. Okay, so first we need to know about boiling point elevation. And boiling point elevation is what delta TB is. So when a non-volatile solute, for example, like a salt or a sugar, is added to a solvent, the boiling point will increase. So when you're adding a salt or a sugar to a solvent, the boiling point is increasing here. And the solute particles will block some of the solvent molecules from escaping as vapor. This results in increase in the boiling point, and that is known as boiling point elevation, which is delta TB. Okay, so so Um, Delta TB is known as boiling point elevation. So delta TB is known as boiling point elevation. So how is boiling point elevation, or what is boiling point elevation? It is formed when a non-volatile solute is added to a solvent. Uh, like the salt or sugar, when it is added to a solvent like water, the boiling point will increase. And this will result in the blocking of some of the solvent molecules. And that is known as boiling point elevation. So delta TB is boiling point elevation. Okay. Then there are different factors which will affect this boiling point elevation. One such factor is molality. So molality means M. Then boiling point elevation constant. Boiling point elevation constant, which is Kb. Okay. B is subscript, okay? So molality means more solute means higher increase. And boiling point elevation constant means which is something constant, the property of a solvent. So these two are the factors which will affect the boiling point elevation. So now let us form or derive the formula. So using the Raoult's law, so now we need to use the Raoult's law using Raoult's Raoult's law. We can say that P is equal to P 0 is superscript 0 X solvent is subscript, okay, solvent. Here P0 is the vapor pressure. P0 0 means vapor pressure. Vapor pressure. Then P is the vapor pressure of solvent. Vapor pressure of pure solvent. P is the vapor pressure of solute. Vapor pressure of solute. And X solvent means mole fraction of the solvent. X solvent. Mole fraction of solvent. Okay. So for dilute solution, the mole fraction of solute will be X solute. Like that. Anyway, so there is a relationship between the vapor pressure and the boiling. So the relationship is found that delta TB is equal to RTB square divided by delta H vapor into delta P. So here R is the gas constant. R means gas constant. TB is the boiling point of the pure solvent. TB, boiling point. Delta H vapor is enthalpy of vaporization of solvent. Enthalpy of H vapor. Enthalpy of vaporization of solvent. And delta P is change in the vapor pressure. Vapor pressure. So since delta P depends on number of solute particles present, or as it depends upon the molality and the boiling point elevation constant, we can say that delta TB is directly proportional to Kb into M. Okay. So this is the way we can derive the equation. So yeah. Next question is, a solution containing 7 gram of non-volatile solute in 250 gram of water boils at 373.26 K. Find the molecular mass of the solute. Okay, so first we'll write down what all things are given. So this is question number 4. Okay, so this was question number 3. So this was question number 3. Next is question number 4. So given thing is mass of solute is given. Mass of solute, which is represented as W. It is solute. Okay, that is 7 gram is the solute here. So it would be W2. 2 is superscript, okay? Sorry, subscript, okay? Anyway, so mass of solute is 7 gram. Then so mass of solute is given 7 gram. Then mass of water is given. Mass of water is the W1, which is 250 gram. But we need to change it into kilogram. 250 gram. So when you change it into kilograms, it would be 250 divided by 1000, which is 0.25 kilogram. Then boiling point of solution is given. Boiling point of solution, that is TB. TB is given. Boiling point of solution is 373.26 K. This means boiling point of water is also the same. Sorry, 373.26 K. Okay. And we know what is the boiling point of water? 100 degrees Celsius. That is boiling point of water, which is TB0. TB0 is 373 K. Hmm. Then the constant, boiling point constant, elevation constant is what? KB. So KB is given. KB is equal to KB of water. Okay, KB for water is 0.52 kilogram per mole is given. Now we need to find the molecular mass of solute. That is capital M is what we need to find. Okay. So first thing is we need to calculate the delta TB. TB we need to calculate. So delta TB is TB minus TB0. So what is TB? 373.26. 373.26 minus 373. So the answer would be 0.26 K. Now we need to use this delta TB. We already derived an equation, right? Delta TB is equal to KB into M. So we are going to use this derivation. So we got delta TB, that is 0.26 equal to KB is what? 0.52. 0.52 into, this is something constant, 0.52 into M. We don't know what is M. So how you will find M? M is equal to N by W1. So M is equal to N divided by W1. Okay. And small letter N is equal to W2 divided by M. So putting it into the equation, we know 0.26 is equal to 0.52 into N is W2 by M. W2 by M is, what is M? M is not given, but W2 is 7. So 7 divided by M, the whole thing divided by W1, that is 0.25. 0.25. So when you put it in properly, you will get 0.26 is equal to 0.52 into 7 divided by 0.25 M. From this, we can find M. How? Just you need to simplify it. You can bring M to the other side. That is 0.26 into 0.25 M is equal to 0.52 into 7. Now from this, you can simplify the M, and finally, you'll get a value of 56 gram per mole. So this is the answer. Okay, so the equation we used is, first we found delta TB is equal to TB minus TBO, then we directly used it into the equation. Okay, so these many equations you need to be aware. Okay. Next question is 2 gram of a substance dissolved in 40 gram of water produced a depression of 274.5 K in the freezing point of water. Calculate the molecular mass of the substance. Okay. So we'll write down the things that is given. Fifth question. So given thing is mass of solute W2 is equal to 2 gram. W2 is equal to 2 gram. Then mass of solute is given W1, that is 40 gram. 40 gram when converted into kilogram, it would be 0.04 kilogram. Then freezing point depression, that is TF. So this is freezing point depression, which is equal to 274.58. Then KF is there. KF is molar freezing point depression constant. Molar freezing point depression constant, which is equal to 274.85 kilogram per mole. We need to find the molecular mass. That is capital M is what to be found. Okay. So now you can use the first equation, that is delta TF is equal to KF into M. Okay. So we know what is delta TF, that is 274.5, and KF is 274.85. 0.85 into M. We already know the equation, into N by W1. Sorry, W1. Then again, using the same method that we used for the above question, N is equal to W2 by M. So now, putting it into the equation, 274.5 is equal to 274.85 into 2 by M. From this, 74.5 into 0.04 M is equal to 274.85 into 2. From this, you can find the M, and M will be 50. So this is the answer. Okay. Next question. Calculate the mole fraction of the solute in a solution obtained by dissolving 10 gram of urea in 100 gram of water. Okay. So first thing is we need to calculate the number of moles. That is N urea. N urea. N urea is equal to, urea will be subscript. Okay. N urea will be equal to mass by molar mass. So mass is given, that is 10, and molar mass is given, that is 60. So when you solve it, you'll get a value of 0.1667 moles. Okay, now we need to find the molar mass of water. Moles of solution, moles of salt. So this is moles of solute. Moles of solute, and solute here is urea. Moles of solute and urea is the solute. Now moles of solvent we need to find. Moles of solvent. And moles of solvent is water. And we already know the molar mass of water. Molar mass of water is 18 gram per mole. 18 gram per mole. So what will be N water? N water is equal to mass into molar mass. Mass is 100. It's given in the question. 100 gram of water, right? So 100 divided by 18. A molar mass of water is something which we needs to be know, which we needs to know. Okay, that is what it is, 18 gram. So molar N, the number of moles in water will be 100 by 18, which is equal to 5.55 moles. Okay, we'll, as we took 4 digits in the above, we'll take 4 digits here also. 6 moles. Now we need to calculate the mole fraction. So mole fraction is X urea is equal to N urea divided by N urea plus N water. Okay, so what is N urea? N urea is equal to 0.1667 divided by 0.1667 plus 5.5556. So when you solve this, you will get a value of 0.0291. So this is the mole fraction of urea. Okay. Next question is, a solution containing 8.6 gram of urea was found to be isotonic with a 5% solution of an organic non-volatile solute. Calculate the molar mass of the non-volatile solute. That is the next question. Okay. So first we need to calculate the molarity of the urea solution. So N is equal to, so we are going to see the moles of urea. Moles of urea, that is N is equal to mass by molar mass. The one we did like above, which is, here it is given 8.6. Mass is 8.6 gram, molar mass is 60. 8.6 by 60 is equal to 0.1433 moles. And in the question it is given, it is dissolved in 1 dm raised to 3, which means 1 liter. So the molarity will be 0.1433 moles. Since the solution is isotonic, so it is isotonic, which means osmotic pressure they will have, which means same osmotic pressure. Okay. Next is we need to calculate the molarity of the non-volatile solute. So we calculate the molarity of urea. Now we need to calculate the molarity of non-volatile solute. Molarity of non-volatile volatile solute. So here it is given a 5% solution is given. 5% solution means 5 gram of solute in 100 milliliter of solution. So 5% of solution means 5 gram of solute. 5 gram of solute in 100 milliliter of water. In 100 milliliter of solution. This means 50 gram in 1 liter. Okay, so if we take the molar mass to be m, then moles of solute will be moles of solute will be 50 by m. So we already know what is the moles of solute, that is 0.1433. So 0.1433 is equal to 50 by m, and 50 by m. From this you can find the m, and the value would be approximately 348. 348.7 gram per mole. Okay. Next question is a 2 gram of benzoic acid dissolved in 25 gram of benzene shows a depression in freezing point equal to 1.62 K. Molar depression constant for benzene is 4.9. What is the percentage association it forms double molecules in solution? Okay, so first we need to calculate the molar mass. So we'll use the formula. Before that, we'll write down what all things are given. W2 is given 2 gram. W1 is given 25 gram, which is equal to 0.025 kilogram. Kf is given 4.9. Delta Tf is given 1.62 K. Okay, so molality that is small letter m is equal to moles of solute divided by kilogram of salt, which means that is W2 divided by m into W1. The whole thing divided by multiplied by 1000. So now when we substitute this, we'll get 2 divided by, sorry, moles of solute by kilogram of solvent. So we can write it down as 1.62 equal to 4.9 into W2 is 2 divided by M into 0.025. From this, you can simply find the M. So when you solve this, you will get M, which is 242 gram per mole. Okay. Now we need to find the percentage association. And it is given that molar mass of benzoic acid. Molar mass of benzoic acid will be 122 gram per mole. So here it is said that benzoic acid dimerizes, which means we can say that the molar mass can become 2 into 122, which is equal to 244 gram per mole. Now, to find the percentage association, we'll use alpha. So, percentage association alpha is equal to molar mass of benzoic acid. That is from what we know, like a theoretical kind of thing. So, let us take this as M1, M1, and this as M2. So, it would be alpha 2 M1 minus M2 divided by M1, and it would be 2 into 122 minus 242 divided by 122. So when you solve it, you will get an answer. Okay, and that would be around 0.8 percentage. 8%. Now the last question. The freezing point depression of 5 into 10 raised to minus 3 molar solution of sodium sulfate in water was found to be. Calculate the degree of dissociation of the salt at this concentration. Okay. So first we need to use the freezing point depression formula. So the formula is delta TF is equal to KF into M into I. Here delta TF is given in the question, which is 0.0265 K. Now KF is also given 1.86 K kilogram per mole. Then M is also given 5.0 into 10 raised to minus 3 m. I is Van Hoff factor, okay? Van Hoff factor. Okay. So now we can put it into the equation. Delta TF is equal to KF into M into I. So now substituting the values, delta TF is 0.0265 is equal to KF is 1.86 into M is given, M is 5 into 5.0 into 10 raised to minus 3 into I. Now, in order to find I is equal to Van Hoff factor, which is, we can find I from the above equation, right? I is equal to, bringing I to the other side, it would be 0.0265 divided by the whole thing. Yeah. So when you solve this, you will get the value of I, which is around 2.85. Now we need to calculate the degree of dissociation. And the degree of dissociation is alpha. So degree of dissociation alpha will be, according to Van Hoff factor, we can say that I1 equal to 1 plus 3 minus 1. This is on the basis of the equation. That is, for Na2SO4, it dissociates as sodium sulfate is equal to 2Na plus sulfate. So when we write it theoretically, we can write I1 is equal to 1 plus alpha 3 minus 1, which is equal to 1 plus 2 alpha. Now, experimentally, or I2 will be 2.85, which we already found. This one, 2.85. 2.85. So now you can put it into the equation. That is 2.85 equal to 1 plus 2 alpha. From this, you can find the dissociation constant. 2 alpha is equal to 2.85 minus 1. And then from that, you can find the alpha value, which will be around 0.95. So there is around 92.5%. So degree of dissociation is 92.5%. So this was the last question. I hope it is clear. If there is any doubt, you could ask me in the next session. Thank you.